so how to help remember your ions. So number one, if the name ends in "ide," it's a negative ion and it only contains one element. So if we have a look through our list of ions right here, right now, you'll see that not all of them end in "ide," only some of them end in "ide." Okay? So the ones that we're going to look for are actually found down the bottom of this table here. The first one that pops into my mind is nitride. Okay? It is just a nitrogen element, but because nitrogen has a negative charge, we call it nitride. So we change the end of it. So it's no longer nitrogen, it becomes nitride. So I can write nitride down here. And out of good practice, I'm going to write N3- in brackets next to it. Start learning those ions. Can you find two more for me with a negative charge that end in "ide"? So we're looking for this suffix. Okay. Phosphide, awesome. Okay, so P3-. So we can write that one here. Phosphide, P3-. And then let's grab one more. Someone else. What's another one? Sulfide, love it. Okay. Sulfide being S2-. Okay, so those are all our negative ions. Now, okay, if it's a negative ion, but it also contains an oxygen bound to something else, we call it a phosphate. So these are going to be some of the ones that we highlighted in green. So can you see two on the board right now that end in -ate, that include oxygen and have a negative charge? Sulfate and phosphate. Great. So our examples are going to be, for this one, sulfate, SO4 2-. And something I'd like to make really clear with SO4 2-, note that the 4 goes down the bottom, okay, next to oxygen, and the 2- goes up the top. And we're going to break this down a little bit in just a second, and I'll just write the last one there, so phosphate. And phosphate is PO4, not 2, 3-. So let's break down what this means very quickly. There's a lot of numbers, and I know it's been a while since you did year 9. So over on the side of your page here, okay, I'll fill it in the same spot as you can. I'm just going to make an example, and I'll make an example out of, let's go with phosphate. So PO4, 3-. And I'm going to write it really large like that. We're going to highlight and label some bits together. Okay? So, number 1, okay? What does this portion here mean, this 3-? What could we refer to that as? It is going to be the charge. Great. So this here is the charge. And you know what? I won't use red because I've already done that. That there is the charge. Now, here's where some people can get a little bit confused. What does, if I highlight it in green, this 4 down the bottom here, what does that one mean? Does anyone know? Great, it means how many elements there are and how many of which element? How many oxygens only. So that tells us the number of element, okay? As in, right below it, how many? Not necessarily that oxygen is number 8, okay? So, how many of that element we have? So how many phosphates do I, or how many phosphorus atoms do I have? 1. Why do I have 1? Because I have nothing written next to it. If I wrote a 2 next to the P, how many would I have? 2. Great. The one I'm going to add now is, what if I add a big 2 out the front? I write it in a different colour. What does this 2 here mean? Any ideas? There's 2 of the whole thing. So this is the number of compound, okay? So the number of the compound, aka how many, okay, of this thing do I have? So if I put a 2 out the front now and I ask how many phosphates do I have, you would say 2. How many oxygens are there all together in my 2 phosphates? 8, because I have 2 lots of 4. How many phosphorus atoms are there in my 2 phosphates altogether? 2. How many are found in 1?
2. No.
Just 1. Okay. So when we're looking at this one here, okay, these numbers all mean slightly different things. So hopefully you've got that written down into your notebook. If you have any questions about it, please let me know. But now that we've taken that detour, let's end up back down here. So if the name ends with ium, okay, it's going to be a positive ion, okay? And it's going to be a positive ion, and generally speaking, our positive ions are metals. So can you go find me a few iums in your ion table, and can you fill them in here? If you find one, do you want to shout it out? And I'll fill it into mine as well.
Sodium.
Love it.
Lithium. Calcium.
Cool. All right. Here's where we're going to get that green sheet of paper in front of you now. And we are going to annotate our periodic tables a little bit before we can answer question 4. So, can everyone pull up that periodic table in front of them? And we'll get to answering this question. What's up?
In the quiz, will we have a periodic table?
No. No, you won't. I don't want to make it too easy for you. So, when we're looking at our periodic table, this is your cheat sheet, right? Okay. If you learn how to use your periodic table well, it's going to help you out a great deal. So I know on my slide here, I don't have a massive amount of room along the top, but I want you to imagine that we're going to have 2 separate sets of numbers running along the top. And here's what I'm going to do to start. Okay. The first bit is each column of the periodic table is what we refer to as a group. Okay. So we have 8 groups in the periodic table. Question.
Do we need colours?
Do you need colours? Not for this. No. So these groups go 1, 2, skip a few, 3, 4, 5, 6, 7, 8. Now, I've left a bit of space underneath because we're going to need that space underneath, okay? So these here in my red pen are what I call the groups.
Can I write it on top?
Right on top of the element, I'm actually going to put something else, okay? I know it's a little bit packed and I am sorry about it, okay? So those are the groups. So if I said, what element is at the top of group 6, you would have a look at group 6 and you would tell me it is oxygen. If I said group 1 is made up of how many elements, you could count up how many elements there are in group 1 and you would say 7. Okay. Now, we've said groups are these things which run down as columns. Okay. Everything that runs across, if I write sort of horizontally on my one here, and don't worry, you won't be writing anything else on the side, these are what we call the periods. Okay. The periods of the periodic table. Okay, so our first period is up the top, our second period, third, fourth, fifth, sixth, seventh, and then we also have all these other ones. Now, do you need to label and number all of them? No. Is it worth knowing that they're called periods? Absolutely. It'll help you out a bit if you choose to do chem in year 11. But for now, let's talk about how you can actually use your periodic table to help you. Okay, so I'm going to grab just a different color here, and we're going to write some things. So in our first group of the periodic table, all of the elements have a charge of +1. In our second group of the periodic table, all our elements have a charge of +2. In our third group of the periodic table, everything has a charge of +3. In our fourth, it gets a little bit weird, okay? It's +4/-4. They haven't made their mind up. They don't know what they want to be. And if we follow that +4, -4 all the way down, can everyone find tin for me, number 50? Okay. When we talk about tin, it can either be +4 or, for reasons that we're going to leave unanswered this year, it can also be +2. Okay. Why? I'm so sorry, but we'll come back to it in the future. Okay, not right now. As we then move, if we've gone +4, -4, what do you think our fifth group of the periodic table is going to be?
-3.
Yeah, bang on. Okay, so -3, minus 2, minus 1. And then when we get to this final column, it has 0 charge. Okay? 0 charge whatsoever. So by now, your periodic table should have started to look a little bit like mine. Are there any questions with anything that we've just done to the periodic table? Yeah? That is relating to, instead of the columns, it is relating to the rows. No, you don't need to worry about it. The groups, however, yeah. And the reason that we've numbered the groups is it comes back to our next question. So, the periodic table can be used to predict the charge of the ions in groups 1 to 7. So, can you give me 3 ions, 3 elements that you could look at that periodic table now and you could tell me what their charge is going to be? Let's go 1 from group 1, 1 from group 2, 1 from group 7. Okay, group 1, give me an element. Hydrogen, okay, and the charge on hydrogen is going to be? Great. 1 what? Good. Okay, so H plus. Okay. Our second one. Let's look at group 2. Don't just give me the one at the top. Give me a cool one, an interesting one. Calcium. Okay. Oh, we've used calcium previously. I'm going to skip that one. Any others? Any other ideas? Radium. Okay. So radium down the bottom, Ra. So we can actually write radium in brackets Ra 2 plus. And now I said group 7. So pick one in group 7 for me. Chloride. Okay. How do we know it's called chlorine versus chloride? What changes? We said it was our first rule at the top. These 4 questions. If it's an ion and it's negative and it only contains one element, we change it from chlorine and we swap the ene for ide. Okay. So for this last one, I'm going to write chloride or chloride, yep. And chloride is going to be Cl. What will the charge be? -1. So I can just write it as minus. Okay? I don't need to write -1. If I just write negative, that is enough for me. Did you have a question? No? Cool. All right. So as we move on down, we've now filled in our periodic table. We've filled in the first page of our booklet together. And what we're going to finish off with today, okay, I know we still have time in our lesson and we'll work through some things, is just this starting point on atomic structure. And hopefully, I really hope, this is a review of year 9 for you, okay? So, if you get stuck, let's go. But here's what I'm going to do. I'm going to fill in the blanks with you, and I'm going to highlight some of the other important words along the way. Hence why I like you to bring a pen and a highlighter with you to class. So, at the center of all atoms is a dense nucleus, okay? A nucleus is something really important. We'll draw one in a second. And it is made up of positively charged particles, and these are known as protons. It is also made up of neutral particles, and these neutral particles are known as neutrons. Around this nucleus, so around this main part of the atom, if you like, is a space for lots of these negatively charged particles called electrons, okay, to hang out. And these electrons are moving really, really, really quickly, okay? Now, the issue there, if they're moving really, really, really quickly, it's hard for us to say where they are at any given time. And what I mean by this, if I told you all to look at our fan right now in the room, this part in the center is going to be what part? The nucleus, okay? And around that nucleus are what on our fan? Yeah, electrons, or in this case, the fan blades. Now, right now, if I just gave it a gentle spin, okay, could you follow the fan blades moving round and round? Now, what happens if I turn the fan on and I put it on maximum speed? Could you follow the individual fan blades?
Yes.
Well, maybe you could, but your head would go like this, right? Or your eyes and your head would, ooh, that's not good. Your eyes and your head would be going round and round and round really, really quickly, right? And so this is the same thing with atoms and electrons, okay? They move really, really quickly. And so as a consequence, we kind of predict where the fan blade or where the electron is going to be. And that ends up in something called the electron cloud model. Okay? Now this was predicted by a person named Schrödinger. Has anyone heard of Schrödinger before? No? Anyone heard of Schrödinger's cat? The cat put in a box, whether or not the cat is or is not there? No? No one? Okay, we'll come back to that another time, I guess. These electron clouds can then be broken up into regions called shells. Okay? So, another analogy, unlike our fan, is if you dropped a pea in the center of a football oval, okay? So just a regular pea, you drop it in the center of the oval, what is the pea going to represent? The nucleus. And so the oval is going to represent the electrons, electron cloud. So, something you will come to learn about me is I'm shocking at drawing, okay? And I would like to apologize profusely in advance, okay? But what we're going to draw now is we're going to draw an atom. And the atom that I like to draw is lithium. Why do I like to draw lithium? It's a little bit easier, okay? So what we're going to do is I want you to find lithium on your periodic table right now, okay? Li. It is in the first group of the periodic table. So what number is lithium? 3. And that number is the atomic number, and it's the same as the number of what? We mentioned it earlier. Protons. So I'm going to draw 1, 2, 3, and I'm going to write a little plus in each of these. I'm then going to do a key over to the right, and my key is going to say that these circles with a plus inside of them are protons. Next, lithium. Does anyone remember what that number down the bottom on the periodic table represents? The mass number. And the mass is how many protons and neutrons there are. So if I have 3 protons, and altogether I've got 7 things, how many neutrons am I going to draw in this nucleus? 4. So I'm going to use a slightly different colour here. I'm going to use black now, and I'm just going to draw 1, 2, 3, 4. And inside each of these, I'm going to draw an N. N. N for Nelly. That's the only thing that came to my mind. Great. So draw my key over on the side, N, and this is neutrons. Now, in an atom, and I do say this carefully, in an atom, how many electrons do we have? Is it the same, or is it more, or is it less than our element? The number of protons. Same, more, or less? Not sure?
Is it the same?
It is the same, okay? Because our atoms like to be really well balanced. And you may or may not remember from last year, I like to draw electrons as E's with a little negative symbol, okay? In the first shell, we're going to have 2 electrons. And orbiting around it is our second shell, which is E with a minus. Now, we will review electrons and electron shells, but I like to just introduce you this year to this one, just to kick that memory into gear. Okay. So, we now have 3 particles. What are the 3 particles that we've spoken about so far in this lesson? Neutrons, protons, and electrons. So, in this little table here, we can do it together. We can go protons, and I'm going to use the same colours I have in my diagram. Protons, neutrons, and finally, electrons. In terms of their location, what do you reckon? Yeah? For which 2? Great. So I'm writing proton then. I should be writing nucleus and nucleus. What about electrons? Atom. Yeah, in the atom. What are they doing? I like to think of the moon when I'm thinking about these ones. What does the moon do around the Earth? Yeah, it orbits the nucleus. Okay. So the location, okay, orbit of nucleus. Okay. And what I'm going to do is I'm actually going to cheat a little bit. I'm going to write below that box in brackets as well, What was the name that we gave to those groups where the electrons can live? Started with H, rhymed with hells. Started with S, rhymed with hells. Yeah, shells. Okay. Okay. Now when it comes to the mass, okay, protons have a mass of 1. Okay. Neutrons are roughly about the same as protons, and so we say that they weigh 1. Okay. But electrons are about 1,840 times less heavy than a proton and a neutron. And so by comparison, we say that they weigh nothing, 0. Okay. When we talk about the charge, we mentioned earlier that protons have a what charge? Positive or negative? Positive. So I'm just going to draw a plus here. Okay. When we talk about neutrons, I didn't draw a positive or a negative because they have no charge. And so instead of like a negative, I'm actually going to draw a 0, meaning no charge. Electrons, as we've represented them, have a negative charge. Negative. Okay. And so when we're talking about the symbol for all of these, just as we've done up here, protons are going to be my positive, electrons are going to be my E minus, and lastly, neutrons are going to be my circle with an N, just like this. So there's one final thing that we need to label in this diagram, and it's everything that is in yellow here. What can I label this region that is named in the nucleus? Great. So this here is the nucleus.